So this next topic is on properties of rectangles. So rectangles have the same properties as parallelograms, but there's two additional ones. So they have opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. They also have four right angles. So I'm going to write here, four right angles. And rectangles, their diagonals are congruent. So you can write these down or you can look at them in the notes. Either way, I included them, so it's up to you. So we're going to use these properties of rectangles to solve for missing sides and missing angles. So let's look at number one. We need to find QR. QR is this side right here. So one of the properties is that opposite sides are congruent. That's right here. So if PS is 10, then we also know that QR is 10. So this is 10. We need to find SR. Again, opposite sides are congruent. So if PQ is 24, then SR has to be 24. Now we need to find SQ. SQ is this diagonal right here. And then we also need to find PR. That's the other diagonal. So one of the properties is that diagonals are congruent. That's right here. So if we find SQ, then we'll find PR. So in order to find SQ, we're actually going to use something that we learned in the past called Pythagorean Theorem. So I'm going to erase these lines here. And I'm going to highlight and show you the two lines that I'm looking at. I'm actually looking at a triangle. So if you look right here, I'm looking at this triangle. Or if you wanted to, you could have looked at triangle SQR. Either way, they have the same dimensions, so it'll allow you to find the diagonals. So if you notice, this is a right triangle. I'm just going to draw my right angle right here. We have PS as 10, SR is 24, and we need to find this missing side right here. So we're going to use Pythagorean Theorem. If you don't remember, it's a squared plus b squared equals c squared. And c squared is always the hypotenuse, which means x is our hypotenuse because that's what we're trying to find. So we're going to have 10 squared plus 24 squared is equal to x squared. 10 squared is 100. 24 squared is 576, and that's going to be equal to x squared. So now we have 676, because I added these two, is equal to x squared. And if you take the square root of both sides, you're going to have x is equal to 26. So that means this side right here, this diagonal is 26, and that is PR. And remember, we said diagonals are congruent. So if PR is 26, that means SQ is also 26. The last thing they asked us for is QT. QT is this halfway point right here. If we said SQ is 26, that means these two have to be congruent. So if we divide 26 by 2, that means this is 13 and this is also 13. So QT is 13. Let's try another example. So in this one right here, again, we have to solve for the missing sides. So the first thing is AC. So if you notice, AE is 15. And if AE is 15, then that means EC is also 15. But they want AC, which is this whole thing. So 15 plus 15, that gives us 30. Remember, one of the properties is that diagonals are congruent. So if AC is 30, then you guessed it, BD is also 30. Now we need to find BE. if we said that this one is 15 and this one is 15, diagonals are congruent. That means this one is 15 and this is also 15. So that means BE is 15. I'm going to erase all of those. Let's erase those. Our next one that we need to find is AB. So if we know that DC is 27, directly opposite sides are congruent, so this also has to be 27. Now we need to find BC. That's this right here. Again, we're going to use our Pythagorean Theorem method. We're going to look at the triangle. This right here is a triangle. We found BD. We already said BD is 30. So I'm going to go ahead and write 30 right here. Remember, this is a right triangle, which means 30 is our hypotenuse because it's across from the 90-degree angle. So I'm going to use Pythagorean Theorem, a squared plus b squared equals c squared, where c this time is 30 because that's my hypotenuse. A squared, let's just say that's 27 squared plus x squared. So if you solve this, 30 squared is 900. We still have x squared plus 27 squared. I'm going to do in my calculator 27 times 27. And I get 729. So now I have to subtract 729 from both sides. That cancels, and I'm left with x squared is equal to 121. Take the square root of both sides, and you're going to see that x is equal to 13.1 when you round it. So that's BC, 13.1. Let's try another example, but this time with angles. So we need to find the missing angles in this rectangle. Keep in mind that one of the properties, let's look back, one of the properties of a rectangle is that there are 4 right angles. 4 right angles. So if we go here, I'm just going to draw in my 4 right angles. So there's a right angle right here, right here, right here, and right here. So they asked us to find the measure of angle MJK. So the measure of angle MJK, that's this whole entire angle right here. And we already said that this is 90 degrees. So I'm just going to go ahead and write that right there. The next angle we need to find is angle MJL. So I'm going to erase this right here. We need to find MJL. This is still a right angle, but I'm just going to highlight what MJL is. So MJL is right here, this little bit in the corner. So if we're looking to find this angle, keep in mind this whole thing is 90 degrees. Let me use a darker color. We're looking to find this angle, but we know this whole thing is 90. If this is 27, I need to find this missing angle so that I add the 27 plus this missing angle, and it's going to equal 90 degrees. So I'm going to do 90 minus 27, and that's going to give me 63. So I know that MJL is 63 degrees. Next, we need to find JLK. So JLK is right here. This is JLK. And remember, we still have some similar properties from parallelograms. So we know that alternate interior angles are congruent. So if this is 63, then this also has to be 63. Next, we need to find KML. We need to find the measure of KML, and in order to do that, we're going to use a different property of rectangles. So we know that diagonals are congruent, right? So we know that this is congruent to this, and this is congruent to this. Well, they're all congruent, so I could actually only use one hash mark. because all of the diagonals are the same. So these are all congruent. So if this is 63, we already found out this is 63. We know this whole thing needs to equal 90. So that means this has to be 27. Also, we know alternate interior angles are congruent. So that's 27. This is 27. And if we know these two sides are congruent, then we know the angles opposite those sides are also congruent. So if this is 27, this also has to be 27. Look, angle opposite the side, and then angle opposite the side. So this also has to be 27 degrees. The last one is angle MNL. MNL is right here, directly in the middle. So we need to find this angle. We can already see it's an obtuse angle, so it's going to be bigger than 90 degrees. So if you're thinking it's 63 or 27 or 90, that's wrong. It's going to be bigger than 90 because if you look at it, it's an obtuse angle. And obtuse angles are between 90 and 180. So I'm going to highlight this triangle right here. So this is triangle M and L. Remember, triangles always add up to 180 degrees. We have two angles here. We have 27 plus 27 plus some angle X. We don't know what that angle is, but that's the angle that we're looking for. It needs to add up to 180. So if we add these and we subtract it from 180, we're going to see that X is equal to 126. So that's this missing angle right here. Now let's get into solving using variables. So this is very similar again to when we were using parallelograms last week. Same property, opposite sides are congruent. So we're going to set these two equal to each other. We have 3x plus 5 is equal to 7x minus 39. I'm going to go ahead and move this 3x. I got 5 is equal to 4x minus 39. Let's add 39 to both sides. That cancels. I have 44 is equal to 4x. Now if I divide by 4, we have x is 11. Keep in mind, it said find EF. So we need to plug it back in right here. So 7 times 11 minus 39. So we have 77 minus 39, and that's equal to 38. So that is our answer. Let's do another example. So we have RT, this diagonal. RT is 5x minus 14. And we have US, this diagonal, is 2x plus 10. With these problems, you have to try and look at the properties of rectangles, and you have to see which one corresponds so that you can solve the problem. So we know that diagonals are congruent. These both are diagonals. So we can just set those two equal to each other. 5x minus 14 is equal to 2x plus 10. I'm going to subtract 2x from both sides because I don't want a negative. So I'm going to have 3x minus 14 is equal to 10. Now I can add 14 to both sides. And I have 3x is equal to 24. Divide by 3. And I get x is 8. However, they didn't ask us for x. They asked for VT. So if they want to find VT, VT is just half. Let me highlight that right now. VT is just half of the diagonal. So in order to find VT, we could actually plug it into either one of these. We could plug it into this or we can plug it into this because they're both congruent, right? But we need to find half of the diagonal. So once we find the length of the whole diagonal, we just divide it by 2. So I'm just going to plug it into this right here. 2x plus 10. But as I said, you could plug it into RT, you get the same thing. So 2 times 8 plus 10. I have 16 plus 10, which is 26. Mind you, this is the whole diagonal. I only need to find VT. So if I divide 26 by 2, I get VT is 13. Now I'm going to show you that if you use the other one, you'll get the same thing. So we'll see 5 times 8 minus 14. 5 times 8 is 40. 40 minus 14 is still 26. And if you've divided by 2, you're still going to get 13. Let's try one more. So this time I am solving for angles. So I have find the measure of angle JHI. So JHI is right here. This is JHI. And you might be wondering, well, they didn't give us a measure for JHI. We don't even know what equation to use or anything like that. What you do remember is that alternate interior angles are congruent. So that means this angle is congruent to angle JHI. Let me put them in the same color. So these angles are actually congruent. But we're not going to solve that way just yet because we need to find x first. So remember, in a rectangle, we have 4 right angles. So this is a right angle, this is a right angle, this is a right angle, and so is this. So this is supposed to be a right angle. We know 12x minus 17 plus 3x plus 2. If we add these two angles together, we're going to get 90. So let's set that up. 3x plus 2 plus 12x minus 17 is equal to 90. I'm going to combine like terms. 12x and 3x, I have 15x. 2 and a negative 17, I have minus 15 equals 90. I'm going to add 15 to both sides. I have 15x is equal to 105, which means x is 7 if I divide by 15. So I'm going to go ahead and plug this 7 in because I said this angle is congruent to this angle. So we know 3 times 7 plus 2 is going to give us the measure of that angle. We have 21 plus 2. So that means JHI is 23 degrees. Make sure when you're solving for these problems, you are trying to figure out what property is going to be used, whether it's opposite angles are congruent, opposite sides are congruent, alternate interior angles, diagonals are congruent. It's up to you to figure out which property is being used and then use that to set up your equation to solve for x or to solve for a missing side or to solve for a missing angle. That's it. Next up is properties of rhombus and squares.